All right, let's go over homework 12.2, 12.3, number 5. All right, so first we want to see the function f of x where the function is concave up or concave down. Actually, let's pull out the problem first. All right, so we want to see if it's concave upward. All right, so let's do that. Alright, so in order to examine concavity, we have to take the second derivative. So let's take the first derivative first. Alright, so derivative f prime of x is equal to, right? So whenever you have natural log of something, derivative is you put whatever inside the natural log on the denominator. And take the derivative of that, put it on top. So which is this is basically this is a chain rule, 2x minus 4, right? So that's the first derivative. Actually, 2 is in common, so I'm going to just factor it out. So it's going to be 2 times quantity x minus 2, right? So denominator is the same. So x squared minus 4x plus 53. Right? Right, take another derivative. So here we use the quotient rule. Right? So quotient rule says that first square the bottom. So we can do that. X squared minus 4x plus 53 quantity squared. Right? And 2 is just a constant multiple, so I'll put 2 outside. Right, so derivative of the top, which is 1, times the bottom, which is x squared minus 4x plus 53, minus top, which is x minus 2, times derivative of the bottom, which is 2x minus 4x. Right? So let's simplify that. Let's just multiply it out. So you will get, let's see, 2 is outside. All right, so you have x squared minus 4x plus 53, right? Then minus, right, x times 2x is 2x squared minus x times, oh sorry, this is just 4. X times 4 would be 4x. Negative 2 times 2x, negative 4x. Negative 2 times negative 4 is positive 8. Right? Then you have same denominator, x squared minus 4x plus 53 squared. Right? Let's see. I'm going to actually factor out the negative sign too. So it's a negative 2 outside. Right? See if we can simplify a little bit further. Right? So same thing on the bottom, x squared minus 4x plus 53 squared. Right? So negative sign is factored out, so it's going to be a positive 2x squared minus x squared. So it's going to be x squared. Right? So it's going to be negative sign factored out, so it's going to be those guys combined together is negative 8x, and this is going to be plus 4x, so it's negative 4x. Right? Then, so that's going to be 8 right here, then minus 53. So it's going to be negative 45. All right? Then we can factor out the numerator. So it's negative 2 is still there, right? And then you have, right, we can factor this out as x plus 5 times quantity x minus 9. Then you have x squared minus 4x plus 53 quantity squared. Alright, so first we're going to set that equal to 0. You can see that this is going to give us x equals negative 5 and x equals 9. Alright, so let's do the number line to examine the concavity. Alright, so we have negative 5, so I'll just put it here, and a positive 9. Alright, so we can try anything smaller than negative 5, so I'll probably try negative 6. Alright, so if you plug in negative 6 here, so it's negative, negative, and negative. So negative times negative times negative. Since there are odd number of negatives, so it's going to be negative. Alright, so you have a negative sign here for the second derivative. Alright, so anything between negative 5 and 9, we'll try probably 0. Alright, so if you put 0 here, positive, negative, times negative, so it's going to be positive. So that's going to be positive here. Alright, so try anything bigger than 9, so I'll try 10. Alright, positive, positive, negative, so it's negative. Right, bottom is always positive because of the square, so it's negative here. Right, so you can see that f is concave upward between negative 5 and 9. So f is concave upward on open interval from negative 5 to 9. Alright, let's see if that's the right answer. I go here. Alright, so I'll put, alright, so it's going to be negative 5 to 9. Alright, then let's check the answer. Alright, so got that one right. Alright, so intervals so concave downward. Alright, so concave downward on negative infinity to negative 5, comma, 9 to positive infinity. Alright, so let's check that. Alright, got that right. Alright, last thing is x coordinate any inflection point. So I like that correct. Okay, so we can see that the inflection point is going to occur right here, since concavity changes from concave down to concave up. So there will be an inflection point here. So inflection point at negative 5. And also at x equals positive 9, there will be an inflection point there as well, since concavity changes there. Right? So it's going to be going back. So it's going to be at negative 5 and also positive 9. Right, and check the answer. Right, that's it. Right, that's it. I hope that this was clear.